In data mining, hierarchical clustering is a method of cluster analysis which seeks to build a hierarchy of clusters. Strategies for hierarchical clustering generally fall into two types. Agglomerative: this is a bottom-up approach, each observation starts in its own cluster, and pairs of clusters are merged as one moves up the hierarchy. Divisive: this is a top-down approach, all observations start in one cluster, and splits are performed recursively as one moves down the hierarchy. In general, the merges and splits are determined in a greedy manner. The results of hierarchical clustering are usually presented in a dendrogram. In the general case, the complexity of agglomerative clustering is, which makes them too slow for large data sets. Divisive clustering with inexhaustive searches, which is even worse. However, for some special cases, optimal efficient agglomerative methods are known, SLINK for single linkage and CLINK for complete linkage clustering. Cluster dissimilarity: in order to decide which clusters should be combined, or where a cluster should be split, a measure of dissimilarity between sets of observations is required. In most methods of hierarchical clustering, this is achieved by use of an appropriate metric, and a linkage criterion which specifies the dissimilarity of sets is a function of the pairwise distances of observations in the sets. Metric: the choice of an appropriate metric will influence the shape of the clusters, as some elements may be close to one another according to one distance and farther away according to another. For example, in a two-dimensional space, the distance between the point and the origin is always 1 according to the usual norms, but the distance between the point and the origin can be 2 under Manhattan distance, under Euclidean distance, or 1 under maximum distance. Some commonly used metrics for hierarchical clustering are, for text or other non-numeric data, metrics such as the Hamming distance or Levenshtein distance are often used. A review of cluster analysis in health psychology research found that the most common distance measure in published studies in that research area is the Euclidean distance or the squared Euclidean distance. Linkage criteria: the linkage criterion determines the distance between sets of observations as a function of the pairwise distances between observations. Some commonly used linkage criteria between two sets of observations A and B are, where D is the chosen metric. Other linkage criteria include, the sum of all intra-cluster variance, the decrease in variance for the cluster being merged, the probability that candidate clusters spawn from the same distribution function, the product of in-degree and out-degree on a Kelvin nearest neighbor graph, the increment of some cluster descriptor after merging two clusters. Discussion: hierarchical clustering has the distinct advantage that any valid measure of distance can be used. In fact, the observations themselves are not required, all that is used is a matrix of distances. Example for agglomerative clustering: for example, suppose this data is to be clustered, and the Euclidean distance is the distance metric. Cutting the tree at a given height will give a partitioning clustering at a selected position. In this example, cutting after the second row of the dendrogram will yield clusters A, B, C, D, E, F. Cutting after the third row will yield clusters A, B, C, D, E, F, which is a coarser clustering, with a smaller number but larger clusters. The hierarchical clustering dendrogram would be as such. This method builds the hierarchy from the individual elements by progressively merging clusters. In our example, we have 6 elements A, B, C, D, E and F. The first step is to determine which elements to merge in a cluster. Usually, we want to take the 2 closest elements, according to the chosen distance. Optionally, one can also construct a distance matrix at this stage, where the number in the ith row jth column is the distance between the ith and jth elements. Then, as clustering progresses, rows and columns are merged as the clusters are merged and the distance is updated. This is a common way to implement this type of clustering, and has the benefit of caching distances between clusters. A simple agglomerative clustering algorithm is described in the single linkage clustering page. It can easily be adapted to different types of linkage. Suppose we have merged the 2 closest elements B and C, we now have the following clusters A, B, C, D, E and F, and want to merge them further. To do that, we need to take the distance between A and BC, and therefore define the distance between two clusters. Usually the distance between two clusters is one of the following: the maximum distance between elements of each cluster, the minimum distance between elements of each cluster, the mean distance between elements of each cluster, the sum of all intra-cluster variance, the increase in variance for the cluster being merged, the probability that candidate clusters spawn from the same distribution function. Each agglomeration occurs at a greater distance between clusters than the previous agglomeration, and one can decide to stop clustering either when the clusters are too far apart to be merged or when there is a sufficiently small number of clusters. Software, open source frameworks. Cluster 3.0 provides a nice graphical user interface to access to different clustering routines and is available for Windows, Mac OS X, Linux, Unix. ELKI includes multiple hierarchical clustering algorithms, various linkage strategies, and also includes the efficient slink algorithm, flexible cluster extraction from dendrograms, and various other cluster analysis algorithms. Octave, the GNU analog to MATLAB, implements hierarchical clustering and linkage function. Orange, a free data mining software suite, module ORNG clustering for scripting in Python, or cluster analysis through visual programming. R has several functions for hierarchical clustering, CCRAN task view, cluster analysis, and finite mixture models. For more information, scikit-learn implements a hierarchical clustering based on the Ward algorithm only. WCA includes hierarchical cluster analysis. Fast Cluster efficiently implements the 7 most widely used clustering schemes. Standalone implementations. CrimeStat implements 2 hierarchical clustering routines, a nearest neighbor and a risk-adjusted, RNNH. Fig is a JavaScript package that implements some agglomerative clustering functions and functions to visualize clustering output. Cluster is a Python implementation, based on NumPy, which supports hierarchical clustering and plotting. Hierarchical agglomerative clustering implemented a C Visual Studio project that includes real text files processing, building of document term matrix with stopwords filtering and stemming. Multidendrograms, an open-source Java application for variable group agglomerative hierarchical clustering, with graphical user interface. Graph agglomerative clustering toolbox implemented several graph-based agglomerative clustering algorithms. Commercial MATLAB includes hierarchical cluster analysis. SAS includes hierarchical cluster analysis. Mathematica includes a hierarchical clustering package. See also, statistical distance, Brown clustering, cluster analysis, Cure data clustering algorithm, dendrogram, determining the number of clusters in a dataset, hierarchical clustering of networks, nearest neighbor chain algorithm, numerical taxonomy, optics algorithm, nearest neighbor search, locality-sensitive hashing, notes. References and further reading, Kaufman, L. Rusi, P.J. Finding Groups in Data, An Introduction to Cluster Analysis. New York, John Wiley. ISBN A0-471-87876-6. Hasty, Trevor. Dishirani, Robert. Friedman, Jerome. 14.3.12 Hierarchical Clustering. The Elements of Statistical Learning. New York, Springer PPA 520 €528. ISBN A0-387-84857-6. Retrieved October 20, 2009. Press, W.H. Tucholsky, S.A. Bettling, W.T. Flannery, B.P. Section 16.4. Hierarchical Clustering by Phylogenetic Trees. Numerical Recipes, The Art of Scientific Computing. New York, Cambridge University Press. ISBN A978-0-521-88068-8A.